101. So in this training, there have 2 sessions. The first session is for the 101, and the second session is for the 201. So in the first session, there have the basic introduction for the upstreaming, and in the second session, there have the example driving the session. So in these 2 sessions, we will to split 2 hours, and we will have 1 break. So let me give some brief introduction for myself. I work for the Linaro solution and support team. So it is the first previous time my leader, Daniel Thompson, delivered this session in San Francisco. So he suggested me to deliver this session in this time connect, because he supposed here have many Asian face. So he suggested me can take this session in this time. So let's begin for this session. So let's see the agenda. In this session, we will to focus on the Linux kernel upstreaming, because there have other community in open source, for example, for the Android or for the firmware. So they have their own other standards. So in this session, we just focus on the Linux kernel standard for the upstreaming. And we will to get to see what's the upstreaming, define what it is first. Then we are to check how to upstream, because for the upstream, there have the process and there have the mechanics. So there have skills you should to get to know for the process and for the mechanics. And for this session, the target audience is the developers, but it also will be helpful for the managers. This is because for the upstreaming, it will take related long time. So the managers will get to know the process, where to help for the managers to define the schedule in the company. So the prerequisites is in this session should assume the family with the source code control concept. In particular, should to family with the Git terminology. For example, for the Git pull, or they have the Git tree, the topic branches for the Git pull request to the upstreaming, and also should to have the technical understanding of Linux kernel software. So what is the upstreaming? Again, for the upstreaming, we just based on the Linux kernel, this context. So upstream means to move software into the top level Linux repository. So what is the top level Linux repository? This is the Linux towards Linux repository, or usually we also call the mainline. So let's say if we access the website, the kernel.org, this website, we can see here it's tagged as the mainline kernel, because there have other versions of the kernel, but the mainline kernel is maintained by the Linux himself, because there have other maintainers in the community. So there have some stable or long-term support the kernel version, but this version is not maintained by the Linux himself. Here have one thing is that in some companies, they call their own production branch as the mainline. This is where usually we are to introduce the confusing. So in the Linux kernel open source community, if we call that the mainline kernel, just refer to the Linux, the Git tree and his branch. So if we access this linkage, we can get to know who contributes to mainline. In this page, we can see there have many companies. They were to they contribute to the mainline kernel, and also there have many individual developers contribute to the mainline kernel. But for the companies, actually they have different purpose for contribute to the mainline kernel. For example, there have many big companies. Maybe they want to charge the technical direction. So they want to contribute many patches to the mainline kernel, and they also want to on the front of the technical development. And also they have such like the silicon companies. They develop the software, but they want to reduce the cost for the maintenance. So they want to upstream their own code to the mainline kernel. So finally, they can avoid too much cost for the maintenance. And also, you can see there have many open source community, the companies, such like the Nilaros. They support the 96 board. So they want to support the wear for this board on the mainline kernel. So also there have many upstreaming for this board. But actually, different companies, they may have different strategy. So they may have different purpose for the upstreaming. So swimming upstream to mainline, in the Linux kernel community, they have distinct hierarchy of repositories. So that means that the Linux is the top level repository. Everyone wanted to merge the patch to the Linux repository. But actually, when we send out a patch, but the patch will not be directly merged by the Linux. Our patch will be merged firstly by some maintainers. So they have a hierarchy for the Git repositories. They have different maintainer, or they have different subsystem or component. Then for every different component, they have dedicated repositories. So when the repository, they wanted to send out the pull request to the Linux, they usually will to send out one or more the topic branch pull request to the Linux. So for example, if for the ARM SoC, if you want to send the pull request to the Linux, usually they were to send out topic branch, one for the DTS, and maybe another is for the SoC related stuffs. So in one repository, there maybe have different branches. And for each repository, actually the owners is quite different. Sometimes the repository may have one maintainer or owner, but maybe they have one repository, they have one maintainers. One maintainer may have, it maintains different repositories. For example, the Mark Brown, he maintains for the regulator, he also maintains for the ASOC, such like a repository at the meantime. So for the SoC company, usually in the company internal, they will have some platform team. So the platform team, they will maintain the repository by themselves. So there maybe is not only one person, it's a team to maintain for the repository. So we can see in this upstream code flow, we can see this is a hierarchy for the upstreaming. So when you send out your patch, you will to only to send a patch to the some maintainers. This maintainer include, if we take as ARM SoC, we can see they have the CPU, and in the SoC they have the peripherals and the device. And the SoC will be mounted to a board. So on the board, they also have the PMIC, regulator, codec, such as this kind device or chips. So they have different maintainers for the subsystem. So we can see they have subsystem maintainers such like the pin control is maintained by the Linux, and they have the regulator is maintained by the Mark Brown. And in the subsystem, there have many drivers. So some simple drivers can be directly maintained by the subsystem maintainer. But maybe there have one driver is very huge or very complex. For example, for the USB driver. So there maybe have a dedicated maintainer is just only maintained for one driver. So if you write the patches for this complex driver, the patch will be first only merged into this driver's maintainer. And then finally, this driver's maintainer will to ask the subsystem maintainer to merge related patches. And there have architecture maintainer. For example, for V8, 64, the maintainer is Catlin and Will Deakin. And for the 32, the maintainer is Ruskin. So they have different maintainer. If you want to change some code for the cache maintenance, or you want to change some very common architecture code, you have to send the code, the patch to the architecture maintainer. There also have some the feature maintainer. Feature maintainer, we can take it as the common features in the Linux kernel, for example, for the file system or the scheduler or the networking. So they have different maintainer for the features. So here I have one concept is when you patch merge it into the subsystem maintainer or architecture maintainer and the feature maintainer, then finally they will to send the pull request to the Linux. Then when your patch has been merged into the Linux repository, then we can call that your patch has been merged into the mainline kernel. So let's see what's the who is maintainer. Maintainer is a component code owners. So the component may be a subsystem or just only a drivers or scheduler, file system or networking, or maybe architecture and platform. Maintainers are responsible for a slice of kernel tree. Maintainer also is a gatekeeper. So when you send out patch, maintainer have the responsibility to review your patch. It will to control the acceptance of incoming patch. So that means that the maintainer is the only path for your patch can be received, accepted by the Linux kernel. But our maintainer actually they have different favorites. So some, for example, some maintainer may have very strict requirement for your coding standard or coding style. And maybe some component they have very, very different requirement for the device tree binding. So for example, for the clock driver and for pin control driver, you can see there the device tree binding is quite different between each other. So in this case, you should get to know these maintainers, what's his favorite and what's his preferred method for your submit patch for this component. So this will be help you to easily get your patch merged quickly. So now we can see if we search in the Linux kernel, the documentation, the maintainers, this file, we can now get to know for 4.14, this version, the maintainers have 1,087, the maintainers. So each subsystem or component have one or more maintainers. In the file, we can see every entry there have for one maintenance performance, maintenance info. For example, for the ARM port, this is for ARM 32, this part. The maintainer is Ruskin. So here also have a Ruskin's mail address. So when you send the patch to the Ruskin, you can use this address. And there also have the mailing list. So in this mailing list, when you send the patch, you should to send the email to the Ruskin, this maintainer. Also, you should to send the email to the mailing list. Ruskin himself also maintain one website named www.arm.linux.org.uk. In this website, there have many detailed information for you how to send the patch to the ARM SoC. There also have some subsystem for Ruskin himself to tracking the patches you send to him. There have status is maintained. That means this part has been maintained well. But sometimes some modules had the maintainers maybe have move away, or he have no interest on this area. So maybe the status changed to often. So that means the component has not been maintained by anyone. And the folder is acham. So let's say we should to understanding merge windows. This is quite important for us to upstream kernel, upstreaming the patch to the Linux kernel. Merge window open when open every 10 weeks plus or minus 1 week. Merge window is open for 2 weeks. So in the merge window, these 2 weeks, Linux will to merge all the new functionality patches into his tree. So that means in other release cycles, Linux just only merge the bug and fix the patches. So if you write a new driver, the new driver only can be merged in the merge window. And other times, the new functionality driver cannot be merged. So here I have one thing that we can see this merge window is very exactly based on the Linux, his time scale. It's not based on the maintainer's scale. So merge window planning. So if we want to merge our own device driver, the new functionality need to be accepted by the maintainer tree, usually by RC6 or RC7. After RC7, most maintainer will only be accepting fix. So that means that if they have RC8 or RC9, RC8 or RC7, but the maintainers usually they want to take any risk. So after that, they don't want to take any new functionality drivers in their own repository. So finally, your patch cannot be merged into the Linux repository. So that means less than 7 weeks after the merge window close to have a maintainer queue or patch for next merge window. So for example, here I have 3.16 RC1. Here means that the Linux have closed his previous merge window. So from here to the next merge window, here have more than 7 weeks. But before the next merge window, the maintainers usually will to stop to merge the new functionality patches before the RC7. So that means here have still have some period for the maintainers. They don't want to pick more new functionality patches. So that means they have give you not enough time for you merge your new functionality driver. So let's say how to upstream. So first thing, let's see how to do the preparation. First thing we should to know the content. When we contribute to the Linux kernel, the first thing we should to know is what's the current implementation in Linux kernel, and we need to know where for our hardware design or the SoC design. So we need to write the software driver to fit into current Linux kernel framework, because when you upstream the kernel, there will get many feedback or comments for why you do it like this way, or what you are doing, and how you doing, how you doing in driver. So if there have many detailed information or questions, you should give the response. You should get aware to know why you do like this way. Another thing is that when you try, actually, usually there have some, one mistake usually the new developer often to make mistake is new developer or usually want to write their own the new API, or they want to change the framework. So that means that you will to change the framework or new API. That means that the current framework can meet your requirement. But usually you write the contribution, first thing is to make sure you can conform to current framework standards and the kernel APIs. So if there have the case that you current framework cannot meet your requirement, if you review the code, the first thing I think you should to do is you should to send the email to the mailing list or the inquiry this question in the IRC channel to get some suggestion. Otherwise, maybe you aware to waste your time because maybe you have the misunderstanding for the framework or you are on the wrong way. Here have another thing is to know who else is doing work in your area upstream. So when you write the driver, you are using the old API, but in the meantime, there have another new another developer is developing a new API. So in this case, maybe the another driver, his patches has been merged into the Linux kernel firstly. So that means your work should has been waste time because you should to rework your patches to use the new APIs. So first thing you should to know is you should to subscribe the mailing list to get to know if they have related work where to impact your own self. So you can use this way to make sure they are not to waste your time. In the Linux kernel, there have many documentations in the folder documentation. There have many docs to clarify on API and the frameworks. From the previous experience is now when we deliver upstreaming the patches to the Linux kernel, there have many regression on the DT binding. So the first thing you can do is to review documentation device driver binding. There have many existed the best examples. For example, if you write the mailbox driver, maybe you can see there have some mailbox directory binding for some other platforms have done. There have also another resource you can access is to access the mailing list. In the mailing list, there have the DT binding best practice. But here you should to know one thing is for the DT binding, every different component, they may have quite different requirement. For example, for the clock driver, they want to binding like, as the global IP version. But for the pin control, you can see there have many DT binding is based on the regulator or separate pin. So they have different requirement. You just to only to search the part related with your errors. So for the public discussing, there have two common methods. One is using the mailing list. In the Linux kernel, there have a global mailing list, is Linux kernel mailing list. There also have many mailing list is dedicated for the subsystem or component. And for the IRC, it's like a public chat room. So everyone can see what you're seeing. So if you access, log into the IRC, you can ask some question. So there have many public discussing in these two open place. So follow this forum and understand the direction the frameworks are moving in APIs and style. If you have any question or confusing, you can ask questions. If necessary, to clarify what APIs to make use before writing your code. So this can help you to save your time. For ARM SoC, here I have one suggestion is to read the Linux ARM kernel, because in this mailing list, there have the patches for ARM32 and the discussing for ARM64. So if we want to very quickly to get familiar with the Linux kernel's community culture, so this is a good place you can understand for it. For IRC, you can log into the free node. There have very many, a lot of the channels. For ARM Linux, there have one channel is ARM Linux. In this channel, there have discussing for the ARM architecture related, the kernel discussing. Just now we discussed how you prepare for you write your code and how you say there have discussing. But when you want to send out your patch, you should to read the document in the Linux kernel. Is documentation submitting patches. In this doc, it explains how you generate your patch, how you send out your patch, use the tools. And there have a submit checklist. There have many check items, not only for the operation for your patch coding standard, also there have many checklists for you check your code's semantics, such like this. And for the device tree, there have some special requirement for you submitting the patch. So you should to get to know, for example, the device tree, you should describe the binding is only for the hardware property, but not the software description. So many times when we send out the patch to the mailing list, will be rejected because you define a new DT binding, but it's not really a hardware property. And when you submit patch for the DT binding, the DT binding will be as the first patch, and then you can use a later patch to use this DT binding. So there have the sequence requirement. Greg, before he write these documents in his blog to describe what's the things you should to avoid when you send out the patch. For example, in the very early time, there have some guys to send a patch as an attachment. So I think that now most of these mistakes we will not make because we can use the tool. For example, we use the Git. Because before we have no the Git send email, so usually we should to manually send email with the email client. So here have one thing is that we should to use the correct tool to help us to avoid to make the mistake. So let's say when we create the patches, the first thing we should to use Git for code management. Because as I know, even now, there also have some companies, they don't use the Git internally. But if you use the Git, you will find that it will to make your life very easy, much than other version control tools. And when you send out the patch, because you will have many modifications for your code, so you should do logical division of commits. So if you in your patch, if they have the bug fixing, or they have a clean up for the code, and also they have code for the new driver, such kind of things, if you write in only one patch, it will be that the maintainer is hard to review. So you should to split these patches into several small patches. And you should to group the patches as a functionality. Here have another thing is very important is that every patch should individual complete. So that means the patch should be bicycle ability. So that means that every patch when it be merged into the code base, it cannot break the building. It also cannot break the runtime. So if, for example, for a long time, they have merged many patches, then we found there have one issue. So we want to go back to know which patch have introduced this issue or this failure. So we can use the bicycle ability. We can use the bicycle method to find which patch have introduced this failure. Another thing is that if you use a small patch and the logic commits, it will let the maintainer to easily to review your patch. So you will to save the maintainer's time. So finally, you can get your maintainer's attention and easily to help you merge your patch. When we send out the patch, usually they have two different kind format. One format is you send the patch as a series, so they have multiple patches to send out at one time. And another method is you send the patch only one patch. So if you send out the patch as series, there will have the a number to indicate 1 of 11. That means there have 11 patches, but this is the first one of the patch. So when we write the patch, there have the subject for this patch. It will to describe, brief to describe the patch's purpose. So its format is here have a patch and its tag name that is a number for the patch, and it will to indicate what's the subsystem the patch for, and finally is the summary phrase for this patch. So when you send only one, when you send a patch, you will to get some feedback or comments. So you should to write, fix your patch, and you send out the next one. So here in the patch subject, you will to use the tag V2 or V3 to indicate your latest patch to the maintainer. So maintainer can easily to get to know which patch your latest patch. So when he wants to merge, he will to use the latest patch. Sometimes if you want to send a patch not for merge, you just want to discuss, launch some discussing. For example, you have some idea for some framework change, or you want to just to some idea for your own code. So you can just to send out an RFC patch. This way the maintainer to get to know, oh, this patch you don't want to be merged, but you want to get some discussing or some request for some comments. The commit log message is quite important, so take time to create a quantity commit log message. In the commit log message, it needs to describe why the patch is needed, what the patch implemented, how the patch is implemented. So the below is a pattern you can to use is the condition info didn't handle case bar and the break platform BAZ. Add an additional conditional and arrow pass to full to handlebar. So you should to explain what's the reason your patch and what your patch implemented and how it do the things. And if you have patch serials, every commit must have where from the commit log. And we should to take the patch not only for a commit, it's also a part of your patch. So it also will be merged into the code base. So it will, for a very, very long time later, maybe some guys can check this commit log. When you send out a patch serials, you can use the, when we generate the patch, we use the command, is get format patch. And we can use the parameter Carbonator for patch serials. So in the Carbonator, we will to describe the whole story to the mailing list, what are your patch serials to do. Because every patch only just explain this patch itself doing what thing. But you will to tell the world what's the whole story for the patch serials. So you can use the Carbonator to do this thing. When you send out the patch, there have one script to help you to check the coding standard, and the semantics is the check patch, the per script. And if you want to get to know the maintainers for your patch should to send out, you can use the script get maintainer this per script to verify the maintainers list. When you send out the patch, you can add the maintainers to the 2 line. So we can know that because there have many traffic for the mailing list. So if you want to make sure the maintainer can receive your patch and get a review, you should add the maintainer to the 2 line. And for the mailing list, you can add them into the CC9. And you can search it in your file. There maybe have some related, interested parties. So you can add them into the CC9. So that means you also want to get some feedback or review from these related parties. When you send out the patch with the mail, you can use the git send email to post patch and the serials. So you don't need to send a patch by the mail client anymore. And after you send out patch, usually we think we have finished all the things. But actually, this is just start. For you, there maybe have many iterations for the comments, and you send again and get other comments again, and you were to send new patch serials. So you should expect the comments. That means that maybe there have many iterations after you send out the first version of the patches. So feedback on mailing list. Usually when we want have sent out the patch, we want to get the response from the maintainers. So that means that you get the attention from the maintainers and get comments. But if you have no response, please be patient. Maintainers usually have some reasons, maybe they cannot to review your patches. But sometimes the reason is because the maintainer themselves is very busy. For example, they are on the holiday or on the trip. But sometimes, for example, if you send out your patch very huge serials, or the patch is very big, so you should get to take care if the patch have not good logical division or lot, so that maintainers will leave your patches and not give any time for the review. If you wait for 1 week, they have low response, you can resend, or you can also inquiry in the IRC channels if possible. So sometimes you can get some response on the IRC channel. If maybe you can get to know what's the reason. For the feedback, there will be expected to have many tough questions. So be prepared to justify your decision approach in great details. So you need where to review your patch, what your patch is doing, how your patch is doing, why you use this way to implement it. So there have many details questions come from the review and comments. So you should to reply these questions with very detailed information. Because the maintainers, they have very long time background for this area, so they have very good, strong back knowledge for this. So usually they can provide very valuable comments, and usually they are right. But sometimes if you think maintainers are not always correct, you should be strong and concise in your justification. So when you reply the comments, you should use very concise description to ask some question or confirm with the maintainer or review. Here, I think my personal experience is usually the native English speaker can very easily to catch each other's the point. But for some time, for example, my native language is Chinese. So when I read the English, the mail, sometimes I really need to take some time to very quick, very detailed to read the mail multiple times and reply to fix the mail. So this way, should you take some time to do this thing. If you don't understand a comment, ask for clarification. So usually there have, because sometimes the maintainer will give a very brief comments. Maybe these comments you cannot catch the point. So please just to ask the maintainer to help to clarify. Maintainers will be very happy to do this. And don't ignore comments, because if you ignore the comments, that means the maintainer will to remind you once again your next version. So this will be waste time for the maintainer. Also, that means your next version patches also cannot be merged into the repository. When you communicate with the mailing list, you should to use a send email client. So in the Linux kernel community, there have several very common use the email comment, the client. For example, the Mart or the Thunderbird. So use this client, you should to send the email just with the plain text format. Please don't use the HTML format. And please don't reply the email with the top posting. You should to use the inline comments, the method. If we work on the patches, there you maybe get many different comments. So when you want to discuss comments and want to very quickly to get the conclusion, the best way is you can use the thread method. Because in the thread method, maybe there have several sub-thread. So you can use only one sub-thread to just to discuss one complex question. And so you can use this way, can focus only one discussing. If there have many patches in your mailbox, so you want to apply this patch on your own code base, you can use the client to save the message as the format that Git can recognize. So Git can directly to apply this patch with this format. In the Linux kernel, there have a documentation in mailclients.txt. This file will to advise on configurations of various mail user agents. So there have given many configuration for different email clients. For the new developers, they send out the patch. Usually they have big concern because usually there have many arguments in the mailing list, or there have many fights in the mailing list. But actually, for the new developers, no need to worry about this if you are following the documented practice. So usually this will not happen to the very new developer in the community. Everyone will to help you to get familiar with the environment. Make changes, be responsible, address comments while discussing, and come to a conclusion quickly. So when you want to get your patch pre-merged quite quickly, the first thing is very important. If they have discussing or if they have questions, you must to get a conclusion. And based on the conclusion, you should to send out next version patches. So, and if they have some agreement, you should to use the incorporate agreed upon comments and quickly submit a new version. So if you send a new version in a very short time, you can catch the attention from the maintainers. Otherwise, for example, if the maintainers give you comments and you wait for 3 weeks, 4 weeks, then it will be cooling down. And when after 1 month or 2 months, you send out the next version, maybe the maintainer needs to take more time to get familiar with the previous discussing. So you should actively to respond to the comments and send out the next version in very short time. So you can keep your discussing warm. Be prepared to not get acceptable comments resolution on the first try. So usually there have many iterations, or there have many discussings. Expect many iterations. When you resend your patch, you should to increment the version number in the subject line for the patch series, and including a changelog. So in the changelog, you will to explain in this time you have some different compared to the previous version's patch. Once the patch has been accepted, so the first thing, the later things you should to do is maintain your patch or your code. So there have many maintainers or the developers in the kernel. They have the reputation. I think this is not because they contribute many patches. This is also because they take a very long time to create the reputation based on the maintain their own code. So need to follow in the mailing list for upstreaming the changes. Also help review any new changes within the same area as you contribute. And if there have any new patches, you can help to testing for the patches. So the summary, preparation is the key to success. Read the manual on everything. Ask questions. Act with a sense of urgency on comments. And understand the merge window timing. So this is the things can help you to merge the patch with a good progress, good process. So this is the first session. We will to take 10 minutes, and in next session we will to deliver the upstreaming 201.